Okay, so today's inequalities again, but we're using multiplication and division. So if you remember how to do this from equation way, it's the same thing. And then I think tomorrow, next week, we do two-step inequalities, but for today. All right, so here's an example. So I'm just going to show you examples. And for the most part today, you're going to have to graph them also with your homework. So we're going to make sure we know how to graph again, too. So a few of them you got to graph. So this is 8x is less than or equal to 40. Okay, so let's just take a step back and say, okay, if I had this, how would I solve it again? What would I do? Remember? How would I solve for x? McKenna? I'm going to divide by 8 on both sides. Okay, so x equals 5. And I'm going to solve it the same way, even if it's an inequality. Divide by 8, divide by 8. X is going to be less than or equal to 5. So I'm going to solve it the exact same way. Except for remember, you have to have, when you write an answer to an inequality, you have to write it like this. Because what's the difference between inequalities and an inequality and an equation again? Do you remember? This is number 14 on your homework today. What's the difference between an equation and an inequality? This is an inequality. This is the equation. What's the difference between the two, Desi?
Inequalities are either like less than or below, like equal to or below.
Okay.
And the equation is actually
Just for that answer, yep. So equation is just this. X can only be 5 here. Well, what can x be up there? What can x be up there? What could it be? 5, 4, 3, 2, 1, because that says x is less than 5, right? So inequalities, we can have many answers. Equations, we can only have one. That's it. Do you remember how to graph them? Let's talk about that. This is something I talked about in my other class a little more yesterday than with you guys. How do I graph this answer, Logan? Yep, so 5, and remember it's going to be a snapshot. Oh, 8, look at me, 6, 8, my God. It's going to be a snapshot of what that looks like up there. Okay, open or close dot? Close dot, how do I know? Because of that sign up here, yep, it just tells me. So, and when I close it, what does that mean for the 5? That means it's included in my solution set. Remember, solution set are all the possible answers that can be that x. So when I close that dot, that tells me that 5 is included in that solution set. Now, how do I know which way the arrow goes? How can I figure that out, Haley? 5 is going to be greater, and it says x is less than or equal to 5. So what can x be? You told me it's 4, 3, 2, 1. So it's going to go this way. That's how the arrow would go. What do you mean the other way? See, but your number line should look exactly like up there. You should be able to take a snippet of that number line and put it on your paper, and it should look exactly like up there. So if you have 5, 6, 7, 8, that's not the way a number line should go. So try to make sure your number line is the right way, because pretty soon that's going to screw you and me up if I'm correcting stuff. And so careful. Okay, so let's do one that has division included this time. Okay, so this says d divided by 2 is greater than 7. D divided by 2 is greater than 7. Now, how am I going to solve for D this time? I'm going to multiply. So many people missed this when we learned this, okay? They were dividing by 2, but really this is division. If I want to do division, I got to multiply by 2. Now, if I do it on this side, what do I got to do? The other side. So this is going to be D is greater than 14. So instead of graphing it, let's just talk about what D can be. What could D be? DB. Oh my gosh, what could DB? A lot of letters, yeah. Okay, so what? Give me a number. 15, 16. Is 14 included? No, because it's not the equal to. Good. Nice job. You guys get the hang of this. Okay, so there's one big rule when it comes to doing these types of problems with inequalities. Okay? And this is it. When you multiply or divide by a negative number, you must switch the inequality sign. So you better get this written down. And we're going to do plenty of examples of this. explain what it means and how it works. And don't forget to write the inequality sign, because that's important. Let's switch to the inequality sign. I should just change that in my. So what do we know when we multiply negative and numbers? What do we know about that? Like, what's the rules? Do you guys remember the rules when we multiply or divide by negative numbers? Yeah. Two negatives equal positive. Two different signs equal negative. Here's the thing. Our inequality sign doesn't know those rules. It's just a sign. It isn't aware of the rules. Another thing it's not aware of is if you look at the number line up there, it doesn't understand that when you get to 0, the number line is mirrored. You know what I mean? Like it goes 1, 2, 3, 4, 5, 6, all the way down the other way. The sign doesn't understand that. So we have to physically change the sign to help it understand the rules. So let me show you what this means. Here's an example. I have negative 2g is less than 10. So you know to solve this, what am I going to divide by? Negative 2, right? I'm dividing by a negative number. Okay, and I'm going to do the same thing over here. Well, it's going to give me g, and this side is going to be negative 5. So what do I have to do? According to the rule, what do I have to do to this sign? I have to flip it. All I got to do is flip it. So if it's going this way, I got to flip it this way. And the reason why is because it thinks that 10 divided by 2 is just 5. It doesn't understand that that positive and that negative make that negative number. So we have to change that sign. Does that make sense to everybody? And you're going to, what's that? I know. It's just one rule that you got to remember. When I multiply or divide by a negative number. So here, if I divided by, if this number's negative and this number's negative, that means this sign right here has to flip in my answer. Okay? Well, if you think about it, now okay, so if g is greater than negative 5, what can g be? No. Let's try like, can we try like 1? Can we put 1 in? Because that's greater, right? So it's negative 2 times 1. Negative 2. That makes it true, right? Negative 2 is less than 10. Okay, so let's say we didn't change the sign. Let's say we kept it like this. No, that's still not it. Let's say we kept it like this. So now this would be like negative 10, right? So let's put negative 10 in here. Negative 2 times negative 10 is what? 20. Is 20 less than 10? 20 less than 10? No, no. So it doesn't understand the rules of multiplying and dividing negative numbers. It doesn't understand, like, this problem thinks that 10 divided by negative 2 is going to be positive 5. That's what it thinks. So we have to change the sign so it makes sense to the numbers involved. Yeah. All the time. It doesn't matter what sign it is, you just have to flip it. So really, yeah, that'd probably be a great idea. So this is what the answer should be. Because if I flip that sign and I pick a number, I want it to be true. Now, if I flip that sign, like we said, we put 1 in there, it made it true. 2 would make it true. 3 would make it true. 0 would make it true. But if I would keep it, it would not be true if I tried to put it back in. Just by a negative. Yep, just by a negative. Nothing else. If everything else is positive, you don't have to worry about it. If this number is negative, and I'll do some more examples so you can kind of see when you do and when you don't. So this is an example of changing inequality sign. Okay, let's do another one then. So this looks like this. X divided by negative 3 is less than or equal to 4. So what do I have to do to solve for my x? Yep. Okay, so I'm multiplying by a negative. Check that out. I'm multiplying by a negative, and I'm going to do that over here. So x, and this is going to be negative 12. So what has to happen to this guy right here? I have to flip him. Yep, I have to flip him because that sign doesn't get that that's a negative 12. It thinks it's just a positive 12 because it doesn't know the rules between the positive and negative numbers. That's the answer. Yep. Yep, it doesn't matter what the sign is, you just flip it. It does not matter. So basically, a lot of times the kids kind of figure out anytime the number with the variable is negative, you're going to have to flip it. And this is only for when you multiply and divide, nothing else, not adding and subtracting, nothing else, just multiplying and dividing. They just figure out the number with the variable, if it's negative, that's when they split the sign. Not today because we're only multiplying and dividing. That's only subtraction. Only subtraction. I know. I know. It's just one little thing, isn't it? Yeah. Let me show you a time where you do not change the sign. Okay, so let's say I have 3x is greater than or equal to negative 18. So let's divide by 3. Let's divide by 3. Is that a negative number? No. Even though this is negative, it does not matter. I'm not dividing. This one needs to be negative for me to flip the sign. So in reality, this one is still going to be like this. Okay, so see how I didn't divide by a negative? That 3 was a positive number. It's only if the number with the variable is negative. If this one is negative on the other side, it does not matter. It's only if this guy is negative. So this is the time you don't flip it. That's the time you don't. Excuse me. Okay, let me show you another one. Okay, just so you're kind of on the same page as me, I guess. Anybody still need this one yet? Okay, let me go to this one. Okay, just looking at this one, should I have to flip the sign? Yes, just looking at it. Yep. Yeah, go for it. Go for it. Sorry, I forget to let you try things on your own sometimes. You just got to tell me, can we do this one on our own? I just get too excited. It's 20 divided by 5. Yeah. And you still got to remember your rules because this is going to be x is going to look like this, and this is going to be 4. So your answer should be. Okay? Now if I had to think about this, what are some things x could be? 3. What else? 4. What else? Negative 20. You bet. Because anything that's less than 4. You always keep it interesting, Kara. You're doing a great job.
I don't know why. Negative, I get confused because in my head, I think of -4, and then if it's greater than, I think of -20 because it's greater than.
I know, but you have to get out of that because if you think about, if you, that's what she's saying. She knows she's wrong. But I think you got to think of temperature. What's warmer, -4 or -20? Right, so that's the greater number. So the farther you get down that number line, the smaller the number is going to get. And I always use temperature because temperature is, everybody can relate to the temperature. So the far, like, is negative 100 or negative 20? Which one's warmer? Negative 20, so that's greater. So negative 20. I know, you just got to get in the habit of thinking it that like that. Yep. All right, so the next thing we're going to do is we're going to write them out again. Remember what we did yesterday? We're going to kind of write them out. They're going to give you a sentence, and we got to write them out. So 4 times the number is greater than 12. Write that out. We'll decipher it. We'll help each other out. 4 times the number is greater than 12. And you got to know these keywords. Remember, there's some keywords in there that are going to help you. And what lesson did we do that day that you wrote all those signs down? Was that yesterday? A few days ago, right?
Yesterday. Yeah.
2 days ago. It wasn't yesterday.
Yeah, it was.
That showed you the keywords for each sign.
It was solving inequalities.
By adding or subtracting. So, okay. You might have to flip back there to know what sign you're working with. Maybe if I turn my Sensi on, it'll warm it up in here.
It might feel warmer because of the scent, but you said
Maybe. The first one. Yeah, we'll do the first one together. 4 times the number is greater than 12. And if you remember, it's going to be set up just like what we were talking about. You guys ready? So what I would do is I would start separating things again. 4 times the number. What does that look like? Is greater than. What does this look like? So what does 4 times the number look like? 4x, or 4 times x. Yep, so this, 4, whatever that is. I was going to make a y, evidently a 4 at the same time. 4x greater than 12. That's what your inequality looks like. Okay, that's what your inequality looks like. Times the number. A number is always a variable. Anytime it says a number, that's always a variable. Fine. Oh, you put 4 times a variable. Oh, that's a good idea. Yeah, that'll work. 4 times a variable is greater than 12. Yeah, anytime we talk about a number, it's something we don't know, and you can use a variable for it. Yeah. What if I said 4 times the number is at least 12? Then you'd have to go back and figure out what sign it is. I think it's greater than or less than. I think it's or greater than or equal to, I think is what it is. I've been working on this with 8th grade too, so I'm getting better at it. Yep, today. So the quotient of a number in 5 is greater than 20. That's all that they want. Well, and then they might want you to solve it, but you guys know how to solve it, right? You can solve it. Divide by 4, divide by 4. X is going to be greater than 3 if you solve it. Yep, if you solve it. Okay? So what about this one? The quotient of a number in 5 is greater than 20. What does quotient mean? Dividing, you're right. So the quotient of a number in 5, and usually when you have division involved, they want it in the order that it's given. So a number and 5, the quotient of a number in 5. They always give it in the order that they wanted to, especially when they talk about division. So that's the quotient of number 5. It said this first, a number in 5. It said it in order. When you are given division, it's always given in order. Is greater than 20. You can solve it if you want. Multiply by 5, multiply by 5. This one we don't have to change any sign because it's not negative, so x is greater than 100 if you solve it. Those are kind of fun after a while. Come again? 200 would be an x, 300 could be an x, 101 could be the x, 102, 101.1 could be the x, literally anything just above 100. Sure. 100.1. This could be it. That could be it. I mean, anything that's just above 100. Doesn't matter. Doesn't matter. Yeah? Okay, so, any others? Let's see. I think that's about it. Okay, what questions do you have for me? Does everybody understand the big rule?
Yes.
Okay, so if you have a number that's with a variable, most likely your sign's going to change. Somebody will forget that. Somebody will forget that. So it'd probably be a good idea before you even start to go look at which ones you think are going to have to be flipped anyway. That'd be a good idea. Let's look at what your homework is. I didn't even